So I'm on the soccer analytics team at Teamworks. We're a group of mostly data scientists and engineers that help clubs with pretty much whatever their data needs. So we have data scientists that build like our own custom models and metrics, and then we have engineers like me who help build the platform to service that data to the users. And that could be through like our web platform. So we have a couple of web applications or like data exports. So we're going to focus on the web platform today because that's mostly what I worked on.
Good.
And I wanted to talk about our journey with DuckDB. So this started out with a slow query. Like one day, one of our data scientists noticed that they were querying a table. It was taking longer than expected. And it wasn't just like kind of annoying, a little bit slow, but you can get around it. It was a simple filter was taking like 20 to 30 minutes. Doing the same thing in R was taking about 2 minutes, so there was clearly something wrong here. So they brought in our engineering team and said, hey, like help me figure out what's going on. So together they troubleshooted, they tried the typical steps you would do with SQL, explain, analyze, to look at the query plan, see if you can modify the query. They looked at creating indexes. That wasn't really going anywhere. Eventually they did the Hail Mary and threw into ChatGPT, and that didn't get anywhere. Well, eventually they landed on DuckDB, and that ended up being the solution. So I'll go into a little bit more why, but that's how this story started. That's how we started using it, and we've been using it ever since. So if you imagine we have a table where like each row is a player, we might want to have like, we have a whole bunch of information on that player, right? Demographic information, like their nationality, age, kind of the typical metrics you would see or you might get from like a skill corner, goals and assists, maybe some other vendors' models, and then we have our own models. And some of those models have like component models that they're built off of. So altogether, this table had about 300 columns. So if you're like a software engineer, data engineer type background, your eyes are probably getting really big. Yeah. So the problem with that is what Postgres looks at data, looks at a table, and it thinks of a table as chunks of rows, right? It's a collection of rows. So what happens is, that's how Postgres processes its data, right? So if we want to filter on age, like we want players under 20 or something, what we have to do is read one row, and then it picks out the age value and compares it to the filter, reads the next row, does the same thing. So it has to read the entire row just to get the one value out. So in a table that's 300 columns, that's kind of like 300 times more work than it actually needs to do. And that's just because of how Postgres is designed. So that's why it was slower, but why was DuckDB faster? DuckDB takes the opposite approach. So it views tables as a collection of columns. So when we wanted to filter on age, for example, all it's got to do is read the one column. It doesn't have to read all the other data that it doesn't care about. And so what this really comes down to is like Postgres and DuckDB are made for different things. So Postgres is what we call transactional database. So it's good at doing like inserting a row, updating a row. It's really meant to work with one row at a time. But DuckDB, on the other hand, is what we call analytical database. And so it's good at doing like aggregations and joining tables. And it's designed to churn through a whole bunch of rows at a time. And so we were kind of using Postgres in an unintended way that worked for us. But eventually we got to sort of the breaking point, and we had to turn to DuckDB. And this problem got even worse on our website. Instead of one slow query, well, on our one table, our website uses many tables. We have a lot of joins, and we do a lot of aggregations, so that this problem compounds. And so to give an example, the type of aggregation we might want to do, imagine if we have a table where each row is one player, each season they've played, every role or position they've played, every team they played on. Like I might want to see how they did like in each season over the last whatever season. Somebody else might want to see how they did in each role. Those types of these types of operations of data processing is not as well suited to Postgres as it is to DuckDB. And so collectively, with more data, we have more people, we have multiple users reading the data at a time instead of one data scientist and one table. This problem just compounded, our website got really slow, and it just degraded the user experience. It just wasn't fun to sit there and wait for your data to load. And again, the reason why is just the type of processing we were doing with Postgres is not really suited for it. DuckDB is meant for the type of things we were doing. But we had all this data in Postgres, we didn't want to just like throw it out. So the solution we landed on is we'll copy the tables we need, like we know we're going to need to use, into a DuckDB, and then store that so it's easy to access. And then when a user comes into the website, we'll do whatever processing of joining and aggregating. And we'll point to the DuckDB database instead of the Postgres. And this was actually like really like plug and play. We effectively just took our queries and put them in a different spot. The syntax is so similar, we just had to make like minor changes. And so people didn't have to wait as long. It was a lot easier to use the website. And what I've been working on a lot is a new website, and
it's great time.
It's a way to improve on some of the things we've done before, and because of that, there's more complexity involved with it. So DuckDB was great when we said instead of querying this Postgres table, we're going to query these DuckDB tables. It was a lot faster, right? But we're still doing that processing at runtime. So if we can do that ahead of time, it's going to be even faster. Right, so we're not doing that aggregation as the user's logging on. No matter how fast DuckDB is, it's going to be faster if we can write that data ahead of time and then just read it. So we started with this like DuckDB of these tables that we've copied over Postgres, and we can say aggregate by player and season, and maybe that's like data set 1, and then another aggregation would be player and role, and then that would be like data set 2. So we do all this processing ahead of time. And then if we do that, then at runtime, all we have to do is read the table. And like we only have to read one data set at a time. We don't have to read a lot and then combine them and then do all these other operations on them. And one of the things we're trying to improve on our new website is, yes, we need to aggregate data, but there's kind of a downside with that is we lose information. So again, if we had this table where each row is one player per season, per role, per team, if I want to look at how this player did per season, what happens to the role and the team information? It gets lost, right? It gets aggregated out. So it'd be really cool if we could like hold on to that information somehow. And so do that, we leverage DuckDB's type system. And in particular, we use DuckDB calls a list, which is like an array, another thing which is just a list of values, and then a struct, which is like key value pairs, so like maybe a dictionary in Python. And if you combine these together, effectively what you get is a table. So instead of throwing that information away, we're effectively aggregating into a table and then storing that as like a nested table within our overall table. And the reason why we do that is we can retain that information. So if you look at like, this is just made up, this is not a real player, but if we wanted to look at how they've been doing in each season, right? Originally, we don't have this role and team information, so we don't really know. But if we keep it together, then we can see, hey, they were on MLS Next in 2023, and then they went to MLS, so like maybe they're a homegrown player that got signed. Like you can see they're getting increasing minutes each season, so they're probably performing well. And so you can see that along with your player by season aggregation. And we don't display it exactly like this. We clean it up a little bit nicer for the users, but this is effectively what it looks like. It turns out doing that with DuckDB is really fast, but it's also really cheap. So we were doing a similar thing before in R, where when we aggregate, we preserve this information, a little bit different structure. If we did that for all these combinations of, player by season, player by role, by team, it would be about $20,000 a day. As we clear, we're not spending that. We didn't spend that. We did some tests, and this is an estimate. We are spending less than $20 a day on DuckDB. And of course, it was a lot faster. So it's fast. It's good for the engineers. We like things to go fast, but it's also good for the business as well. Okay, so we had this one query, one table was slow. But on our website, we have more tables. On our new website, we want to save this information, so we have this more complex data structure. Working with those data structure can be kind of hard. If you're an R user, if you have a nested table, you can have a table inside of a table, but it's kind of cumbersome to work with, and it's pretty slow. So those pre-aggregated Parquet files that might be, one player per season, just reading the file takes about 10 seconds with R, because it has to wants to convert the nested data into a column of data frames. And then ends up being pretty slow. We don't want our users to have to wait 10 seconds, right? If you open up Instagram and it took 10 seconds to load, you would think something's wrong, it's broken. It's really hard to work with too, because if you want to get at one of those nested tables, you have to index into the row and then the column, and then just because of how R works, you have to index into the list, and that's just to get to the data, and then you have to process it. As you might have guessed, DuckDB can do that a lot faster. So it can read one of those pre-aggregated files in about 60 milliseconds, which is 160 times faster. And it's quick enough that users aren't really going to notice it. But in that same time frame, along with reading the data, we can do some more processing on it. Maybe we want to pick a few columns or a final filter, or we take that nested data and format it in a way that's easy for users to see on our website. So we can do a lot more in a lot less time.
Good.
So that's how we've been using DuckDB. And we've had good success with it. So we've been looking well, what else can we use it for, right? It's kind of solved all these other problems. And so one of the things we're looking to is called Duck Lake, which is a data lake house powered by DuckDB, which if you're not familiar, it's a whole bunch of files that is usually on an S3 type thing, and then a database to catalog the files. So we can think of it kind of like a library where each book is each one of these data files, and then you have your library catalog that tells you where they're at. What files do you have and where they're at? And there's a lot of nice things about this. This is according to the Duck Lake people themselves. These are the key features that they call out. But you can do really cool things you can take snapshots at points in time. So you can say, we had a bug come up. It was sometime in last week. I want to time travel back to last week and query the data as if we were in last week. And then it allows you to change. So let's say you get a new column added at some point. You don't have to go back and add that back to every single table you had before and set it all to null. DuckDB has some magic behind the scenes where you could just treat it as if it was always there. And another really cool thing is Duck Lake will support it's fully ASI compliant. So in particular, you can do concurrent writes. So with DuckDB, plain DuckDB, you can't have two people or two processes writing to the same file at the same time, which a lot of times you're going to want to do if you're processing a lot of data. But Duck Lake will let us do that. All right, so yeah, just to recap, we've been using DuckDB a little over a year, and we've had really great success with it. It started out as one slow query, and it turns out we were using Postgres in kind of the wrong way, and we had pushed it to its limits. The issue that we ran into with this one table compounded once we got to our website and we had many tables and more processing. And then with our new website, we want to improve on that and process ahead of time. And the data structure needs are more complex. And looking towards the future, Duck Lake is on our horizon. So like maybe next year, somebody else from the team will be talking to you about how great Duck Lake is. That's it.
Sounds like that.